We're now going to move on to look at mutually exclusive and complementary events. So these are two types of events that you can have in a scenario where you're looking to find the probability of something. A mutually exclusive event means that we have no outcomes in common. All right, no outcomes in common. It's an either-or scenario. So you could have either heads or tails when you were flipping a coin. You could roll either odd or even when you were rolling a die. You could pick out either a white minty or a green minty from a packet of minties. You can't pick out one that's a little bit white and a little bit green. You can't roll a 3 and a 2 at the same time on a dice. So mutually exclusive means that we can never have a crossover. And that can be represented in a Venn diagram, as we were learning last time. So if we've got our universe here, with our N at the top there, and we just have two completely separate circles for A and B. So let's say you were picking letter tiles out of a Scrabble bag, you would be able to either pick out any one letter. There would be no overlap between those letters. So you would have 26 circles separated in your Venn diagram. If you were picking out of a bag that just had A tiles and B tiles in it, then you would either pick an A or a B. You couldn't pick one that overlapped them both. There's a rule for this to make making the probability calculation a little bit simpler for you. We have the probability of either picking A or B as your favourable outcome. And another way we can write this is just work out the probability of picking out an A and add it to the probability of picking a B. So that is your rule for mutually exclusive events. So as I said, either flipping a coin and getting heads or tails, rolling a dice and only getting a 1. Every other event is not a 1. So you can work out the probability using this rule here. Complementary events then, these aren't events that make you feel good about yourself. These are events that have only a set possible number of outcomes. So for example, rolling a dice, you can have 6 outcomes and that's it. There's no other possibilities that you can have on a 6-sided dice. If you flip a coin, you can either have heads or tails. It is certain that you will get either one of those. So a complementary event is talking about the only possible outcomes. And the handy bit about this is that there is a 100% or probability of 1 chance that you will pick one of these outcomes because they are the only possible outcomes. And we're going to demonstrate this with an example. So let's say you had in a packet of minties, you've got 10 green and 20 white. All right, and you're going to pick one at random. What is the probability of picking a green? So we're going to look at the probability of picking a green one. Now the first one we can do, so remember your equation, we've got P event is equal to the number of favourable outcomes over the number of possible outcomes. So for our question, we're going to have to adapt that equation. So our event is to pick a green. So the green is equal to 10, because we've got 10 green ones, out of 30, which is equal to 1/3. If we wanted then to look at the probability of picking a white one, we know we've got 20 white ones and 30 altogether, so we get 2/3. Now, as I said, remember, this either adds up to a probability of 1 or to a percentage chance of 100, because it is certain that we will either pick out a white or a green minty. Alright, so we've got a 1/3 chance of picking out a green, 2/3 chance picking out a white. Together that equals 1. We've got 3/3. That is a fraction equivalent to 1. And our percentage-wise, 33.3 recurring and 66.6 recurring will add to 100%. So we can have a rule for this one. So we'll do the rule in a different colour so that you know to remember it. So our rule is P of the event plus the probability of E prime, and that is everything outside the favourable outcome of that event. So in our case it would be P, the probability of picking a green one, plus the probability of anything else, and in our case that was picking a white one. So remember, this prime goes back to your Venn diagram, and it's everything outside that space, and they are always equal to 1 or 100% if we're working in percentages. So that rule then applies for any event that is complementary. So if you go back to our devices, if we were looking at the probability of people who had a laptop, then our only two outcomes would be having a laptop and not having a laptop. So that would be a complementary event, and those probabilities, the probability of picking someone at random and them having a laptop, added to the probability of them not having a laptop, would equal to 1. So those, we've also looked at mutually exclusive rules today, where we're using this word or again. So there's no outcome in between, it is either or. We're looking at the two favourable outcomes of picking A or B, and we know that we can just add the probabilities of those singular events together to get the overall probability of that event at the end.